This video is all about the Jasmine framework from the point of view of an Angular developer. Here's the test file when you create a new Angular application using the CLI. Notice the file name ends with .spec.ts. Spec stands for specification, a detailed description of the requirements of something. In this case, it details what the app component is supposed to do. The .spec extension tells the compiler it's dealing with a test file. You typically run the spec files with npm test. It opens up the browser because Angular loads the component onto a real browser, HTML and all, so you can properly test it. Here you can see the component. Going back to VSCode, the tests are passing. This spec file doesn't have much, but let's clear it to start fresh. Don't worry, we'll work our way back to this file. Spec files can have magic keywords. One of them is describe. It's just a function that takes two parameters, a string, and a function for it to run. You can think of describes as blocks used to organize your spec files. Let's add a describe block. Describe a component. And run the test file. Executed 0 of 0 tests. Makes sense since we're not testing anything. Notice that the describe function isn't declared anywhere, yet the compiler doesn't complain. That's because there's a TS file, which tells the compiler to assume the Jasmine framework for spec files. There are many of these global objects. Check Jasmine's documentation for more info. Describe blocks are just functions, so you can put any JavaScript statement in them. And so we can declare variables, do some operations, and even log to the console. Save the file so the tests can rerun. The tests need to restart the browser, that's normal. And here's our console log. Since describe is just a function, we can nest them, and closure rules apply. In this case, these two constants are available to the nested blocks. In Jasmine, tests are performed with the it statement, and assertions are made with expect statements. Expect takes the actual value and it's chained to a matcher, which may receive the expected value. A matcher is a function that compares one value to another. There are many matchers available, so check the documentation. The most commonly used matchers are to be and to equal. To be makes a triple equal comparison between the two values. To equal makes a deep comparison over the values. For example, let's say we have two objects and we want to compare them. Using to equal passes because the object have properties with the same value. If we change it to be, then it fails because the objects have different references. As you can see here, when reporting, Jasmine concatenates the describe and the it block. It's nice if the tests read as normal sentences, for example, a component tests something. But don't get too hung up on naming, you may end up wasting time trying to fit your tests into what is ultimately an arbitrary pattern. With Jasmine, just organize your tests using describes, give your tests a meaningful description, and don't worry too much about forming sentences. Jasmine allows you to run code before and after each or all tests in the suite. The commands are self-explanatory, but let's see them in action. First one to run is the before all. Then before each, because the first test is about to run. Test 1 runs. Then the after each block, and the cycle repeats for the second test. The before each runs, then test 2, then after each, and finally after all. It is possible to set up global before and after functions with custom Jasmine reporters. Let's say we had multiple spec files and you wanted to run a function before the entire process. In your Angular project, go to the test.ts file and add a custom reporter. Jasmine started is called after all of the specs have been loaded, but just before execution starts. When the entire suite has finished, Jasmine done is called. suite started is invoked when a describe starts to run, and suite done is invoked when all of the child specs and suites for a given suite have been run. You can also hook to before and after each test, but those are rarely used globally outside the spec file. A common thing to do is to disable a suite or tests. You can do that by putting an X before the describe or before the it to disable the test. Similarly, you can give priority to a test by prepending F to the spec or test blocks. If your codebase has a lot of tests, consider using fdescribe or fit to force Jasmine to only run a small part of your test suite. We're now in a good position to see a real Angular test file. Component and fixture are declared inside the describe block, that's why they're available to inside the tests. Before each, we'll configure the testing module and then assign the values of fixture and component before each test. Now let's talk about spies. Jasmine allows you to replace an object's method with a special function called a spy. The replacement function keeps track of how many times it was called and the parameters passed to it. In this example, we're taking the object foo, and we're going to replace the bar function with a spy. Note that the replacement only lasts for the duration of the describe, so no need to clean them up. To see a spy in action, let's create a people service. It will have a sigil method called getPeople, which returns an array of names. Then we add it to the module. And finally we use it on the component. We add it to the constructor so the component receives it via dependency injection. Create a people array. And finally a method that uses the service to populate the array. Let's split the screen so we can see the component and test file at the same time. If we run the tests, this spec file will fail because the component requires a people service, which we're not providing. So let's do that. On the testing module, we're going to add the provider for the people service. Notice we're using a factory. A factory is just a function that returns an object. We're using a factory instead of an actual value because, that way we're guaranteed to use a fresh object on every test. We're going to test that the method, fillPeople, sets the array of people correctly. You typically want to test the user interactions of a component, not the implementation, but that's not the topic of this video. If you want more information about testing user interactions, check the links in the description. We're going to use a describe to organize the tests. Inside we're going to have a test that will check if the method sets the array from the service. For the arrange part, we want to get the people service, and then make getPeople return a specific array. The act stage is simple, just call the fill method. And finally for the assert, we're going to check the people array and check that it's the same as the array of our service. Notice we're checking it with to be, so it compares the values by reference. The main point here is that we're getting a hold of the service our component is using. And the Jasmine spy allows us to replace the getPeople function with a stub function that behaves the way we want to. To be clear, we're not doing it to prevent the real method from being called. If we look up, our test had no chance of running the real service because we're telling Angular to provide the component with a stubbed version of the people service. When dealing with simple properties, there's no need to use spies on them. For example, if we wanted to reset the state of the people array before our test, we can just set the property directly. Now let's imagine the people property had a getter and setter which we wanted to replace or prevent from executing. In that case you can spy on the property's getter or setter using spy on property. In this case we're taking the component, and then replacing the set method with a spy function. We could have prevented the real function from being called, but in this case we let the spy call through the real function. We're assigning the spy to a variable because we're going to check that the property setter was called with the right parameter, in this case, our people array. Let's revert these changes and think about what we would do if fillPeople was asynchronous. Let's make the method fillPeople wait a moment before assigning the value from the service. In this case, the test fails because the people array is empty by the time the expect statement runs. It's tempting to update the test with a set timeout function. This has two major problems. The first problem is that it makes the test slower because the test suite has to wait for the asynchronous operation to complete. The second problem is that no expectations run before the test ends. It's only after the test runs that the expectation is executed asynchronously. Here, Jasmine is warning us about the test having no expectations. A solution is to add a done parameter to our test. If we do, Jasmine will wait for this parameter to be called before ending the test. In this case, the test fails because we're not calling the done function, even though the expect runs. It's a nice safety feature from Jasmine to prevent you from forgetting about asynchronous operations. Let's call done after the expect to tell Jasmine we're done with the test. The test passes and there are no warnings. But we still have the problem of slowing down our tests. To fix it, we can wrap the test in a fake async function. It will hijack the application's clock and let us manipulate it. In this case, we want to use the tick function to fake advancing the clock 100 milliseconds. That way we don't have to wait the real amount of time our function demands. We remove the done parameter because we're using fake async. The test is passing without warnings and it doesn't have to wait for the async call to finish, but we can refactor the test a little bit. We don't need the set timeout function because we're advancing the clock instantly. We just need to place the expect after the tick. Should you use done or the fake async function? That depends, but in general you should start with fake async. Advancing the clock is very useful, but sometimes you need to change the behavior of date time itself. Suppose we had a function that returned a value depending on the current date. Let's try to test it. We're going to organize the tests inside a describe for greeting. And have two tests, one for the first day of the month and another for the second. This is where the problem starts. Let's try to test the first test. The greeting will change depending on the day the test runs. We need a repeatable way to run our tests. As luck would have it, Jasmine provides a way to manipulate JavaScript's date object. Before each test we're going to install Jasmine's clock. And then after each test we'll remove it so we don't affect other tests. This will let us mock the date when our tests run. Now we add the test for a day other than the first. And the tests are passing. That's all for now. If you found this video helpful, check out the SimonTest extension for VSCode. It takes care of the most tedious part of testing components and services, stubbing dependencies. SimonTest analyzes your code and creates the necessary stubs, configures the TestBed, and it even generates basic tests. Happy testing!